Hi everyone, in today's lesson we're going to talk about how to find holes and discontinuities within rational functions. A discontinuity of a rational function are the values where the fraction is undefined. These values can be in the form of a vertical asymptote or a hole. What is a hole? Well, a hole is a point at which the graph is not connected but can be made connected by filling in a single point. So if you look right here at this spot, there is an open circle. This is a value where the fraction is undefined, but it's not an asymptote. So that is considered a hole. Here, this is an asymptote of x equals 3. Now let's show how we get this hole algebraically. So let's look at this example. It says, given the rational function x plus 2 over x squared minus x minus 6, same example here, I want to find these two discontinuities, the hole and the vertical asymptote. So we've graphed rational functions before that don't have any common factors, but now we're going to. So the first example, or the first thing that you want to do, is you want to factor. So let's write factor the top and the bottom. And we're basically going to factor these so that we can find the holes. So factor to find holes. So let's do that. So we've got f of x equals x plus 2 over, now I'm going to factor this denominator, figuring out which numbers add to -1 that multiply to -6. So it should be x minus 3 and x plus 2. So now we see that this x plus 2 in the numerator and this x plus 2 in the denominator can cancel. Anything divided by itself is 1. So my new fraction is f of x equals 1 over x minus 3. Now this value that you crossed off is the hole. That's where it's not continuous. So we write that we have a hole at x equals, so I can write it over here, hole at x equals -2. So if we want to find the coordinates of that point, so if you look over here, here's -2, we need to find that y value. What we're going to do is plug in x equals -2 into my new fraction that I've simplified. So the second step, if we want to write it, to find y value of hole, we're going to plug in x equals -2 into the simplified fraction. So this is my simplified fraction. So I want to do f of 2, -2, and I get 1 over -2 minus 3, so 1 over -5, which is -0.2. So the hole is really at -2, comma 0.2, which is the same right here, -0.2. Now how do I get this vertical asymptote of x equals 3? Well, after we factor, whatever is left, which is this guy right here, wherever that is undefined is where the vertical asymptote is going to be. So my third thing is the vertical asymptote is the values that make the simplified fraction undefined. Okay, so my simplified fraction is f of x is equal to 1 over x minus 3. So I set the denominator equal to 0 and solve. So x equals 3. This is my vertical asymptote. Alright, so let's try another example. So let's go on to the back. Okay, so example number 2, finding the holes and discontinuities. So the first thing we're going to do is factor. So we've got f of x equals x plus 5, x minus 5. All I did was do dots with the numerator. Now the denominator looks like I could take out an x, and then I'm left with x squared minus 6x plus 5. And it looks like I could factor that again. 2x, x minus 5, x minus 1. Okay, so really this is my new fraction. Anything I can cross off, negative 5 and negative 5. So my new fraction looks like f of x equals x plus 5 over x minus 1. So the whole will exist. So if we want to write that, my whole is when x is equal to positive 5. Now it's positive 5 because it's the opposite of what's ever in here. This is a negative 5, so if I put a positive 5 in there, 5 minus 5 gives us 0. That's what we want because that makes this undefined. So it's always opposite. So if we want to find the y value of the whole, we plug in 5 into my new function. So 5 plus 5, 5 minus 1. So this becomes f of 5, which is 10 over 20, which is 1/2. So my whole is at 5, 1/2. That is my whole. Okay. Now to find the vertical asymptotes, we're going to look at the values that make this new simplified fraction undefined. So x minus 1, making a t-chart, right? So x equals 0 and x equals 1. So x equals 0, x equals 1. These two are my vertical asymptotes. So normally what we had done in the past is that all of these values were vertical asymptotes. But that's because there wasn't anything that I could cancel. So you always cancel first, that's your whole, and then anything left over are my vertical asymptotes. Okay, why don't you see if you could do example number 3 by yourselves. Hit resume when you're finished to see the answer. Okay, here it is. Okay, what you should have noticed with example number 3 is that there are no holes because nothing was able to cancel. So that's true, there are no holes. The entire function is continuous, and that's okay. Now we're just going to look for the undefined values. You basically are going to set the denominator equal to 0. So we've got a negative 1, x plus 2, x minus 1 equals 0. Negative 1 equals 0, that makes no sense. So we have a negative 2 and a positive 1. So these are my vertical asymptotes. This is a good example. Vertical asymptotes with no holes. The only time you're going to get a hole is if there's a common factor. Okay, now there's a typo on example number 4. You can actually just ignore what this says here. That's not possible. What you're going to do is just solve this one all by itself, same as before. Okay, and I'd like you to actually graph them. So you see how there's a graph down here at the end? I'd like you to graph where the hole is and graph where the asymptote would be. And then hit resume when you're finished. Okay, here's your answer. Okay, so let's just explain what I did. I factored all the pieces and these came out, so I was left with this as a simplified version. So my two holes were at x equals 2, 2 minus 2 gives me 0, and at x equals 1, 1 minus 1 gives me 0. So here and here are where I have my holes. I then plugged those values into this simplified function and found their corresponding y values. Those are my holes. Then I took my vertical asymptote by this simplified fraction and I set the denominator equal to 0 and solved. So that's how I got those values. So if you need to, pause the video, copy this stuff down, and then now I'm going to graph it. Okay, so I have a hole at 2, negative 1/2. So if I were graphing it, there would be a hole there. And then I have a hole at 1, negative 1. So about here. I also have a vertical asymptote at x equals 0, which I'm going to put right on top of the x-axis, because that's the same thing as y-axis, same thing as x equals 0. So it looks like this function is going to go like this, towards this, go up, and now in order to figure out where this thing goes, we need to see if there is a vertical asymptote or a slant asymptote. So that we're going to talk about tomorrow, to how to graph these things in its entirety. But today all we want to focus on is, can we find the holes and can we find the vertical asymptotes? So jot down any questions that you might have, and we'll see you in class tomorrow.